Lesson 8.6, Difference of Squares. In the last module, we multiplied binomials with special products, and in the last lesson, we discussed perfect square trinomials. In this lesson, we're discussing the other special product and how to factor it. From Module 7, you may recall that a plus b times a minus b gave us a squared minus b squared. A squared minus b squared is known as a difference of squares because you have two perfect squares, one subtracted from the other. This occurs whenever there are two different squares. Factoring the difference of squares involves recognizing perfect squares and then taking the square root. So here are the steps. We have a difference of squares. First, you factor out a GCF. Actually, we'll do a step 0. So we can identify difference of squares. We'll factor out a GCF if there is one. In this case, there's not. We take the square root of the first term. The square root of x squared is x. We take the square root of the second term. The square root of 16 is 4. And then we place the square roots in the parentheses with a plus and a minus. So that tells us the x squared minus 16 is equal to x plus 4, x minus 4. Let's try some more examples. Okay, I don't have a GCF. The square root of n squared is n. The square root of 25 is 5. So I'll have n plus 5, n minus 5. No GCF again, so the square root of 4m squared is 2m. The square root of 25 is 5, so this gives me 2m plus 5 and 2m minus 5. Here I have n to the 4th, and any even exponent is a perfect square. Okay, so if I take the square root of n to the 4th, I'm going to get n squared. So taking the square root of an even exponent gives you that exponent divided by 2. The square root of 100 is 10, so this will factor to n squared plus 10 and n squared minus 10. Now when this happens, you want to double check and make sure you don't end up with another perfect square here, because then you'd have another difference of squares that you'd have to factor even further. Here I have 10p to the third. Now 10 and p to the third are not perfect squares, but you can see both of these terms have p's in them, and they both divide by 10. So I'm going to factor out that GCF of 10p, and I get p squared minus 196. Now you may need to double check 196 and see if that's a perfect square or not, and it is. And the square root of 196 is 14. So I have the square root of p squared is p, the square root of 196 is 14. So this will factor to 10p times p plus 14 times p minus 14. So why don't you go ahead and try these 4 and see how you do. Now, it doesn't matter if the variable is in front or in back. If you have a perfect square minus a perfect square, you just take the square root of each and go from there. So go ahead and pause the video, work these out, and then unpause it and check your answers. Okay, check your answers on these. Now, this last example, there were really 2 ways to do it. The first way is the most correct way to factor out that GCF of 7b squared, which leaves you with 49 minus b squared, so you get 7b squared times 7 plus b times 7 minus b. However, if you only factored out a 7, you still have 2 perfect squares. So you could factor it to 7 times 7b minus b squared and 7b plus b squared. However, this is not, it's not standard form. It's not the best method.